So in this video, we are going to talk about another measure of spread. And remember, measures of spread just tell us how far our data values are spread out or how much variation there is in our data. In this particular example, we're going to be talking about the standard deviation. So the definition is that the sample standard deviation, denoted S, measures how far our data values are spread from the mean. So the mean is going to be our point of reference. And so this is essentially saying S is the typical distance or the average distance between a data point and the mean. Okay, the way that we calculate this sample standard deviation is that we start by calculating the differences between each data value and the mean. That's what we have there. We square that quantity and then we add it all up. Okay, we divide by n minus 1 and then we take the square root. Okay, so this is giving us some sense of the average distance from the mean. So the first thing I'm going to do is I'm going to do an example just to show you how the sample standard deviation is calculated. So let's find the sample standard deviation, and I'm just going to use SD for standard deviation of the data values -5, 0, 2, 3, and 10. So this is my data set, okay? And in order to do that, the first thing I have to do is find the mean. So the mean is just given by the average of these values. And there's 5 of them. And when I add these all up and divide, I get 2. So now I'm going to use the formula and calculate the sample standard deviation. And I'm just going to do it all at once. And in this case, the last step is I'll take that square root. Remember here, this is just the sum, okay, over all my data values. Okay, so I'm going to start by taking each data value and subtracting the mean and then squaring that. And then I'm going to add those all up. So let's start with the first data value, that's a -5. So I will take -5 minus the mean, which is 2. And then I will square that. And then this guy is telling me to go on to the next data value, okay, and I'm going to be adding. So I'm going to add, and we have 0 minus the mean, -2 squared. And then I have, let's see, 2 minus 2 squared plus 3 minus 2 squared plus... And then finally we have 10 minus 2 squared. And this sum is divided by n minus 1, so that's 5 minus 1. And then I'm going to continue with my calculation. So we have the square root of, now -5 minus 2 is -7. So I have -7 squared. Plus I have -2 squared. Plus 2 minus 2 is just 0, so I have 0 squared, plus 3 minus 2 is just 1, plus 8 squared. And that's over 4, okay? And that finally leaves me with 49 plus 4 plus 0 plus 1 plus 64 over 4. Which is square root of 118 divided by 4, which is 29.5, square root of 29.5. I get 5.43 ... I'm going to round to just one decimal place, so I have 5.4. That is my standard deviation. So that's basically saying that these values, a typical data value here is about 5.4 units from the mean. So one more thing I want to show you is I want to show you how to punch this into a scientific calculator, an online calculator, so you don't have to do every step by hand like I've done here. So I start by entering square root, and then I'm going to start working on my numerator. So to begin the numerator, I have a parenthesis, And then I'm going to have my -5 minus 2. I'm going to close that parenthesis and square it using the x squared button. And then I'm going to add, and then I have 0 minus 2, close the parenthesis, square it, adding 2 minus 2, close parenthesis and square it, plus 3 minus 2, close parenthesis, square it, and finally I have my 10 minus 2, close the parenthesis, square it. And then I'm going to close the parenthesis for the numerator. I'm going to divide, and I'm going to have my denominator of 5 minus 1. Okay, and you can see, the reason I like this calculator is because you can see here that I entered the expression correctly, because I can see it in the above my entry. So if I hit equal, the answer I get is 5.431, which is exactly what we got doing it by hand. So I would like to show you how to calculate the standard deviation using StatCrunch. So right now I'm in StatCrunch, and the first thing I'm going to do is I'm going to enter my data values into the first column. So I have a -5, 0, 2, 3, and 10. And then I'm going to click on Stat, Summary Stats, Columns. And I select the column, so make sure to select the column. And then you can select whatever statistics you would like. Right now I'm just going to do standard deviation, but you could just leave them all. And then I click Compute. And you can see it calculates my standard deviation right here, 5.43, which is exactly what we got. And I also wanted to point out that with this command, summary stats, columns, variable 1, you can actually just compute all your statistics at once instead of just picking the standard deviation if that's what you need. And then I hit compute. And you can see I have everything here: the mean, the variance, the standard deviation, the median is here, Q1 and Q3. So my 5-number summary is given right here. So just as kind of an example to think about, if I consider the following set of numbers. So the mean of the set of numbers is 50. Okay. And the standard deviation, if you had to guess, you can try to think about it. What do you think the standard deviation would be? In this case, the standard deviation is 1. So the data values don't really vary too much from 50. They're, on average about a distance of 1 unit away from 50. Here's another set of data values. I have 70, 10, 82, 37, 51. Again, the mean here is 50. However, you can see these values vary a lot more from 50. In this case, the standard deviation is approximately 28.3. And what about this set of numbers? 50, 50, 50, 50, 50. So you can see there's no variation here. The mean is clearly 50. And the standard deviation, if you had to guess, would be 0. So one thing I want to point out is that, as the amount of variation increases, your standard deviation, S, is also going to increase. Okay, and the standard deviation, of course, since it's measuring like this, it's the sense of distance from the mean. It's never going to be negative. It's always going to be greater than or equal to 0. Another thing I want to point out is, let's suppose I was to take this data set and I was just going to change one number. So I just change my set. So it's 51, 50, 49, 51. And then all of a sudden I throw in a million. How do you think that's going to change the standard deviation? So clearly the mean is not still 50. But the standard deviation changes drastically in this case. It's about 447,191. So the point here I want to make is that, 1 extreme value or one different data value can drastically change the standard deviation. We say it's very sensitive to outliers, and that's because we use every single data value in the computation.